Although functional, there are a few issues with our calculator that we need to resolve. First though, let's take a deeper look at how JavaScript handles the different data types, specifically string, number, and Boolean, which are known as primitive types. As a quick overview, strings are encapsulated with either single or double quotes, and one quote type can be used inside of the other. Booleans are represented by the values true and false in lowercase and without quotation marks. And numbers are stored as double precision floating points and can be represented as an integer, floating point value, or with exponential notation. In addition to variables being loosely typed, we can also execute operations across different data types and still get a valid result. By valid, we mean that JavaScript will try its hardest not to produce an error which could stop code execution, even if it means giving unexpected results. For example, a mathematical addition performed on a string and two numbers will result in a concatenation. Reversing the expression provides a slightly different result, with the two numbers being added together first, and the result then concatenated with the string. This behavior only occurs when we use addition. Any other operator used across data types would typically result in the value NaN, or not a number, unless all of the data types involved could be interpreted as a number. Let's take a look at some example operations that involve multiple data types. JavaScript evaluates expressions using the standard order of operation rules, respecting parentheses and the different mathematical operations, and along the way, implicitly converting data types as necessary to return a valid result. To write better code though, we should explicitly convert the data types to ensure we get the desired result. There are various conversions available, the most common being between string and number data types. To convert from string to number, we can use the JavaScript parseFloat function, which works like this. We could also use parseInt, which effectively converts and floors the value. To convert from a number to a string, we can use the toString method. It's also useful to know which data type is currently being used for a given variable. To find out, we use the typeOf keyword, followed by a space and the name of the variable we want to check. The result of this is a string identifying the data type, and should be one of the following. There are also times when a variable will have no value at all, and for whatever reason, may not even exist in a given code context. When that happens, the value of the variable is considered to be undefined. This is one of the few things that will cause JavaScript code execution to fail if not handled properly. Technically, the value undefined is also a data type in JavaScript, which means we can check for it in much the same way. You may have already noticed that our calculator is currently giving an incorrect result. This is because the value property on the element provides us with a string, and given the behavior we've just described, our formula is resulting in a concatenation of the delivery value instead of a mathematical addition. There are a few ways that we can fix this. We could change the code to use the value as number property of the input to give us the value as a number. As an extra measure, we could also change the type attribute of the input to be number, which will ensure that only numeric values can be entered. In our current example, this would be sufficient enough to get the calculator working. However, we should also add some logic to convert the values to a number, in case we decide to use the function elsewhere. To compare two values in JavaScript, we can use a double equals to check for equality, or exclamation mark equals to check for inequality. These compare the values of the variables and ignores the data type, so the expression 10 as a string double equals 10 as a number will evaluate to true. To compare both value and type, we use triple equals or exclamation double equals, which gives us a strict comparison. The expression 10 as a string triple equals 10 as a number will evaluate to false, because although the values could be interpreted as the same, the data types are different. Here's a summary of the available comparison operators. When working with JavaScript, it's very common to want to execute pieces of code based on certain conditions being met. One way to do this is to use an if statement, which starts with the keyword if, followed by parentheses, which should contain some comparison logic that evaluates to either true or false. We can then use curly brackets to group any code that we want to execute if the condition evaluates to true. To add additional conditions, we can chain any number of else-if statements onto the end of it using the same parentheses syntax. And finally, if required, we can add an else statement with code to be executed if none of the previous conditions were met. To add multiple conditions to the same statement, we can use either a double ampersand for an AND condition or a double pipe for an OR. We want to add some logic to our calculator to ensure that the delivery charge is greater than a certain value. To do this, we'll create another constant to store a minimum delivery charge, and then add an if statement to our function. If the value provided is less than the minimum, we'll display a message to the user and then stop code execution by using the return keyword, preventing the calculation from running. Next, we'll take a look at how we can make the calculator more visually appealing with some CSS, but first it's time for some activities. You can stay up to date with all of our content by subscribing to our YouTube channel or following us on social media. If you'd like a more interactive learning experience, then head over to websy.academy, where you'll find our full set of training courses complete with hands-on activities and much more.